Welcome back, gang. We are back once again with Daily LeetCode Day 84. We have returned. The hyperbolic coding chamber has returned on a mission to slay more problems. We have a message or a comment from Thomas Wong. He says, "It's not a sprint, it's a marathon. One LeetCode per day after 1 year is over 365 LeetCode questions." True statement. I know people who can go from 0 to hero within 3 months, no code, to weekly contest ranked top 100 global. True, but that's rare, so take it like a marathon, not a sprint. Truer words never spoken, brother. So you guys, if you want access to this wisdom, you're going to want to join the Discord so you can have direct access to T. Wong himself. So you're missing out by not joining the Hyperbolic Coding Coalition. But yeah, legendary comment by Thomas as always. This is true, right? And that's kind of what we're aiming for here. I think a good way to go about it is to only do as much as you would promise to do on your worst day. So imagine your worst day of work with the worst news you could possibly hear, with the worst things probably happening to you personally, and then say, okay, how much am I still going to do on that worst possible day where you have no sleep? For me, that amount seems to be 30 minutes right now. And yeah, that's where we're currently at. So worst case scenario, even if we only do 30 minutes a day, right, after a year, we spent at least 160 hours doing LeetCode. So that's always a feels good man. At least it's 30 minutes we spent doing something to, just try and get better, work at something. So always good to see. Other things, reflections on the grind. I think the grind definitely has been tougher recently. So I'm wondering what things I can change. 30 minutes is uncompromisable, so we're just going to have to stick with that. But there's some other aspects offline that I think maybe I could dial back a bit, because I was trying to compress a lot of things into a short time frame. I think I'm just a little overloaded. So yeah, I think we're just going to be doing some recovery runs still. That being the case, we're going to be grinding out more easies, right? And we're still learning, we're still practicing. So this would be the goal. So we have next on the list, right? We have like 112 solved, most of which are easies, but we'll just go with that for now. And yeah, the next one we have is add binary. I'm going to throw in remove duplicates from sorted list, as well as same tree, and then see how many of those we can do. And then yeah, going forward, yeah, this is what we're going to try and do. Definitely a little bit tired as well. I think you can probably tell from my demeanor. And as a reflection, I think I was looking over the last videos. I think I come off a certain way in these videos, which is very interesting, because I think there's a certain space I have to get into in my head to kind of just focus on the grind. So it's very like mellow and even, right? And that's kind of necessary because it's like a 2 or 3 hour thing. And so I think I can come off like flatlining, but I think that's just part of the grind. So yeah, I'm wondering maybe after the recovery run, we'll be doing a little bit better. But yeah, this is some of the things, sometimes you have to walk so you can run. So I think we're definitely going to be walking for now to see. But yeah, we're going to do some add binary, remove duplicates from sorted list, and then same tree. And then yeah, this is day 84, and it is momentous simply because it is day 84. Thank you for everyone who joined the hyperbolic coding chamber. And yeah, we're just going to jump into it for day 84. So let's see how far we can get. So first we have add binary. Given 2 binary strings A and B, so strings as binary, return their sum as a binary string. Interesting. This reminds me of another problem where we have to do addition. But basically we're adding the 2 numbers together, right, using binary. One thing I think, look at example 1, we have 11 or 1, 1 plus 1. 1, 1 represents 3 plus 1 represents 4. So we have just this 4th bit turned on here. And then we do the same for these two, and this is what we get. We'll know that A and B are at least 1 have a length of 1. Each string, A and B, consists of only 0 or 1 characters. Each string does not contain leading zeros except for the 0 itself. So this is interesting. There's a lot of problems that seem to do something similar with something like this, right? Where we have to be doing some sort of addition on probably a strange number, right? That's in like something weird like base 13. You have to add the numbers together, but usually the number is too large. In this case, it seems like the number could potentially be quite large as well, 10 to the 4, so we can't really store it in a number. So how can we go about this? If we have A equals 11, we'll just sketch some things. I will use TypeScript for this one. If A equals 1, 1, not 11, none of my Vim bindings are saved. That's strange. Or they're not activating. We'll refresh the page. Okay, we seem to be good now. If A equals 11 or 1, 1, right? So how do we go about adding these two numbers, right? Which could be of, unknown size. Yeah, and then my Vim binding is broken again. I'm not sure what's going on here. Looks like I get one character change and then I can't switch back. I wonder if they pushed a bug fix or something, or if, yeah, I don't know. But we'll keep moving. We have A equals 1, 1, right? And B equals 1. But really this equals 0, 1, right? So how can we go about adding this? I think we can do something where we use some elementary addition and just basically carry our numbers across, right? Since we have a similar problem like this where we're adding 9, right? But we can, like, I think the problem is, I don't remember what the problem is called, but it's a similar problem where we're adding 9, or we're adding a 1 to an arbitrarily large number, right? This problem is similar, so imagine if we had 11, I think, or I mean 1, 1, binary representation of 1, 1, and we wanted to add 1 to it. Well, we could simply write it as start from the end, right, of the string, which would be this one on the right-hand side, right? And then from there, right, if anytime we see a 1, right, we're going to want to change it to a 0, right? So we change it to a 0, and we saw another 1, so we'll change it to a 0, right? And then what we'll do afterwards, we'll just push a 1 at the end, which will be an edge case, right? And that seems to be the correct answer here. So I think what we're looking for, right, in the case, oh no, we're not just adding 1. So all right, that's actually not going to work since we're not just adding 1. So I think what we can actually do is add something a little more complex. And what we'll do is we could probably, there's another problem that's similar to this where we have a carry, right? We can have something like a carry, right? And an addend, right? And let's just say we're still going to start from the back, right? Let's say we're adding 1, 1, and 1, 1, both of which represent 3. The output should be 6, right? So we'll add 1 and 1, right? Which means what we actually put in that spot, right? Spot is actually going to be equal to that binary value, right? Mod 1, right? If you do 1 plus 1, we get 2. We do 2 mod 1. 2 mod 1 would actually give us 0, I think. Because 1 goes into 2 with no remainders. So the spot would actually be equal to 1 plus 1 Well, I think what we could say, right, is that carry is going to be equal to, for example, we have access to A and B, right, at the end, right? We have 1 and 1. We could just say 1 plus 1, right, mod 2, right? 1 plus 1 would be 2, mod 2 would equal 0. So that's not going to work. I think we're overcomplicating it with the modulus. There's some modulus problems that are just difficult to, whenever I use the modulus operator, I just end up getting confused for some reason. But I think we can simplify it. Basically, if we have two values, right, if we do 1 plus 1 and our value is 2, right, so we can just say, right, if something like pseudocode, right, if sum, right, so we're going to be starting in reverse, right, but if something like sum, if the sum of both these characters, right, so we'll have 1 plus 1, we'll say if sum is greater than 2, or if sum is greater than 1, right, then we have carry, we'll just say carry equals 1, right. The no vim bindings is really throwing me off. And then otherwise, right, otherwise carry equals 0, right. My brain is like spinning. 1, 1, if sum is greater than, what if we took a so let's try and scaffold this, right? We want to iterate over both of these strings in reverse. We don't really know which string is going to be larger because they could be different sizes for the constraints. So you could add 1 to 1. Then we carry the 1. Still have 0 here, and we carry one more 1. So we'll have 0 B. Maybe I'm experiencing interference. I'm trying to think about the problem, but I keep thinking of the other problems that are similar to this, and then I get stuck in like a thought loop. I think I just need to see the problem for what the problem is. Add 1 and 1, we get 0. Right, the problem being when we have something like this, what if we have 0, 1, 1 plus 1, 1, 1, right? We put a 0 here, then we'd have a carry, this carry would turn 1, 1. Our sum would be 3 here. We'd only put 1. Now our sum would be 2. So we'd have 1. Right, our sum would be 3. Right, then we'd have, because of the carries, and they have 3. Then we have 1 over here. So you'd have another 1. We'd have an extra 1 remaining. This comes out to be 2. In reality, we have 1, 2, and 4. This would come out to be 7, I believe. 7 plus 2 should give us 9. So what does this give us? 1, 2, 4. Wait, no. This is 2, right? 1, 2, 4. We have 4 plus 2 plus 1, which would give us 7. So propagating the ones doesn't really make any sense. Another thing we could do is just convert the numbers to their regular values and just add them together like so, and then return the output as binary. Because handling the binary case is really throwing me off. Yeah, the binary case is throwing me off because when you have an extra carry, it gets pretty weird. You can't just slowly bring it down as you go to the left and add more numbers like you do with base 10 for some reason. Or maybe we did it wrong the first time, right? So let's say we have 0, 1, 1, 0B, 0B. Oh, I think I see how we messed up the first time. We have 4 values, so it should have been added like this. It actually doesn't really change much, but we'll try it anyway. Having 0 here, right? Then we have a carry up here, right? So the sum would be 3 here, but I'm presuming we just put a 1 here, and now we'd have a we have a total sum of 3 here. Right now we'd have 2 here. Right, we'd have a sum of 1 here, and now we'd have 1 here. We still get the same answer. So let's switch our approach. Let's convert the numbers, right? Let's just say we have 7 and 2, right? I think we can just convert the numbers to their actual values, right? Then we'd have something like 7 plus 2, right? For which you could just sum the numbers, right? Let's just sum the numbers, right? You get 9. You could turn that to binary. Now let's say if we have something more complicated like 77 plus 02, right? Let's do something more complicated like 77 plus 42 or 44, right? We do 7 plus 4, which gives us 1. 7 plus 4 is 11. If we do mod 10 on that, we get a remainder of 1, right? So we know what goes in that spot is going to be the sum of the values. Right in reverse. or carry does not equal 0. So if we were to iterate in reverse of the smallest string, right, or while carry does not equal 0, right, we'll have, let's say we have num1, right, and num2, we have access to these values. They're just the numbers at the ends of these lists, right, 7 and 4, right, and we want to have our new number, right, let's just say we had something up here like this, new num, and we'll just say, right, maybe num, right, or new digit, right, is equal to num1 plus num2, right, mod 10, right, because 7 plus 4 is 11, mod 10 would give us 1, which would be the new digit we'd put right here, right, and then we'd say carry would now be equal to carry would now be equal, I want to say carry would be equal to the same thing. No, actually, well, yeah. If we do 9 plus 9, right, we get 18, right? We would do is we put 8 down here, right, and then you carry the 1. Sorry, carry is actually not going to be mod, it's going to be num1 plus num2 divided by 10, right, but floored, right, and we can actually just, yeah, we'll say carry equals math floored plus num2. So let's say we did that, right, we'd say new digit equals num1 plus num mod 10, we put a 1 here, then carry would be equal to num1 plus num2, which is 11 divided by 10, which would be 1, which we would have a carry up here of 1. And we do 7 plus 4, which would equal 11 plus 1, which would give us 12, right? So whenever we do our sum, right, we're going to say it's num1 plus num2 plus carry. Right, and we do 4 plus 7, which would be 11 plus carry, which would be 1, right, which would give us 12, and the new digit that we'd put there would be 2. So we would put a 2 there, which makes sense, and then we'd say carry is equal to math dot floor of not just these values, but the sum divided by 10. Our sum was 12 divided by 10, which would be 1, which means carry is equal to 1 again, which means we have one more 1 remaining, right? And since we've reached the end of our string, but carry does not equal 0, right, we're just going to say 0 plus 1 equals 1, and 1 mod 10 actually gives you 1 mod 10 we had 1, right? So we do 0, right, plus 0 plus 1, which would give us 1. 1 mod 10. What does 1 mod 10 actually give you? I need to check. So 1 mod 10 does give you 1, which is what we thought, but that's kind of confusing, right? Because isn't modulus what you get if you divide a number, the remainder of dividing a number by another number? So if you did 5 mods 10, but we'd have sum mod 10. And then if we did 1 divided by 10, we'd get like a number really, really small floors. We'd no longer have a carry. So I think we can make this work. I think the first thing to do would be to convert the value. So convert A and B to integers. Now I'm realizing this actually doesn't. Actually, no, this does work. Actually, no, this doesn't work. This doesn't work. I guess in a sense it could work, but it's messy because A and B can be up to length 10 to the 4. So to convert A and B to integers, we'd actually have to summate their value using power, right? So maybe we'll just do it this way, the way we know how to do it. Say summate, right, will be given S, which is a string, and will return a number. And the goal here, right, the number is binary. Right, so we'll just iterate in reverse. We'll say let I equals S dot length minus 1. And we'll say let sum equals 0. And we'll say let power equal to 1. Right, I is greater than or equal to 0. We'll do I minus minus. And then we'll do sum plus equal S sub I dot parse int times 2 to the power. And then we do power plus equal 1 and then return sum. So if we just imagine that we had a number like this, 1, 1, we iterate in reverse starting at this index here, which would be 1. We'd say sum plus equal parse int sub S sub I, which would be this one here, times 2 to the 1, which would be so we probably want to start power at 0, right? Because this would equal to 3, right? And 2 to the 0 would be 1, right? We're going to do 1 times 2 to the 1 times 1, which would be 1, then power plus equal 1, and then we'd have 1 times 2 to the 1, which would be 2. And so I think what we can just do and say A base 10 equals summate of A, right? And we can copy it and we'll just say B base 10, and then we'll just do console.log A B to start. And then we'll just return an empty string. We have 5 minutes. So we have 11 and 1. It's not what we're looking for. Oh, it's because we print A and B. The print. Oh, the Vin bindings turning on and off is like crazy. Yeah, I can't. I'm just gonna turn it off completely because it's just not working today. A base 10 and B base 10. So this works. We have 3 and 1, which is exactly what we're looking for. Then we want to add the numbers as normal. But A and B can be much larger than that. I'm realizing that's also troublesome in another way. A and B can be up to 10 to the 4. So even if we're summating to get the power or the base 10 conversion, it doesn't exactly work. So this could work maybe if we use a big int. So now we have them as strings. So I think with big int, maybe, I don't think that's gonna work either. I think we have to let go of this version and just figure out the binary addition. We know how to add 1. So let's try this one more time with 10, 10 and 10, 1, 1. Right? We know the answer would be 101, 01. If we add these two together, we get 1. Right? Then we have a extra or a carry. Right? We put, my question is, what would we put here? The sum here would be 3. Maybe we do 3 mod 2. If we did 3 mod 2, we get a remainder of 1. Okay, and then we have 1, which would come down here, which kind of doesn't make any sense because we're already wrong now. So if we have the sum here, right, we have 3, right, mod 2, we put 1 here, right, and we actually still have a carry of 2, so I'm trolling. We do, even if we do, since we have a sum of 2, right, let's just say since our sum is 2, carry would be sum mod 2, which would actually give us 0. I don't know why this is tripping me up so much. Even our beginning number is already off. Right, we have 1, 1. Right, if we have 1 and 1, right, we end up getting a sum of 3. No, we don't. We have, I'm getting confused. I'm just going to paste this below it. All right, we have 1 and 0, right? The output is 1. Then we have 1 and 1. The output should be 0, and then we would carry the 1. Then we put 1 here. We have 1 and 1. The output is 0. Then we carry the 1. Yeah, what am I'm not understanding. How did I get that number from before? That was not good. So if we just try to make this, take this from a process approach, we did 0 and 1. The sum was 1. 1 mod 2 would give us 1. Right, we had 1 plus 1, which is 2. 2 mod 2 would give us 0. And our carry would be 0. We have 0 and 0. Oh no, wait, our carry 2 mod, we have 1 plus 1 would give us 2. If we did 2 mod 2, our carry would be 0. No, okay, now I'm getting it. Oh man, I get it now. We have 1, I'm just mixing up the processes. 1 and 1, we add it together, right? We'd get 2. 2 mod 2 gives us our digit here, right? But to get our carry would actually be 2 divided by 2, which would give us a carry of 1. We can't even get over there. We get a carry of 1. which we'd put 1 down here. Then we do 1 plus 1 mod 2, which would give us 0 down here, and we'd carry 1 up here. And so that should work. So if we look at it like this, we'll have 2 strings. You want to take the shortest string less than b dot length, right? Then shortest will be a, otherwise shortest will be b, and we'll say longest, right? If shortest is equal to a, right, then longest must be b, otherwise it must be a. And we pretty much want to loop while we haven't reached the end of shortest. And to do that, we'll just say let length equal shortest dot length minus 1 for digits index, right? And we'll say while digits index is greater than or equal to 0, or carry does not equal 0, then we're going to say let carry equal 0 to start, right? And then our sum, right, is actually going to be, like we said earlier, num1 plus nums2 plus carry. So we'll say nums1, which is going to actually be a sub digits index, but the integer version, plus parse int of b sub digits index plus carry. And I think we would actually end up building the string in reverse with this method, because you'd have 1, 0, 1. So we'd actually have a stack that we would use, right? We'd say stack dot push, and we want to push on that value that would go into that spot. And that value would actually be sum, like we said earlier, but mod the base, which would be 2. I want to do digits index minus equal 1. And then additionally, right, we want to set carry equal to the new value. Carry is going to be equal to sum divided by the base, right, but floored. And we want to do some special things just to avoid, actually JavaScript will let us do this. If digits in sub index doesn't exist, it's going to default to null or undefined. In that case, if it does, right, we'll set it equal to 0, which is likely to happen after we go over our shortest, right, and if we still have carry remaining. So we can put 0 here, and then I'll make this a bit smaller. Pull the side back over, get a bit smaller again. And then down here, we'd actually have the value or the string we're looking for, but in reverse. So we could have let word equals some value, and then we'll just say while stack length is not equal 0, right, word plus equal stack dot pop, and then we could return not word but binary. So let's check if this makes sense, right? First we get the shortest, right? In this case, shortest and longest are interchangeable. So it's gonna, shortest is gonna be A and longest is gonna be B, right? Digits index, our start is gonna be a shortest dot length minus 1, which is gonna be index 3, right? 3 is greater than or equal to 0, right? So we're going to say our sum, which actually doesn't exist. We're going to say const sum equals parse int a sub digits index, right, which is going to be 0, right, plus parse int b sub digits index, which is going to be 1, plus carry, which is going to total, they're going to equal 1, right? We're going to say stack dot push 1 mod 2, which is going to be 1. And then we're going to do, right, carry is going to be equal to math.floor sum divided by 2. 1 divided by 2 is going to be 0.5. Floor is 0. Digits index minus equal 1. Now we're going to add 1 and 1, right? Our sum is going to be 2. Sum mod 2 is going to be 0, so we're going to push 0. So we're looking good so far. Then 2 divided by 2 is going to be 1. So we're now going to have a carry. Digits index minus equal 1. So now we're going to be at this 0 here. Right, digits index is going to be 1 for both of these is going to be 0, but we're going to have a carry which is going to be 1, right? We're going to say our sum is not going to be 1. We're going to push sum, which is 1 mod 2, which is going to be 1, which is perfect. And then our carry is going to be 1 divided by 2, which is 0.5. Digits index minus 1. So now we're going to finally be at the end, which with 1 and 1, 1 and 1, right? 1 plus 1 is going to give us a sum of 2. And then we're going to push 2 mod 2 on, which is going to be 0, which is perfect. Carry is going to equal 1 because 2 divided by 2 is 1. Digits index minus equal 1. Now digits index is no longer greater than or equal to 0, but carry does not equal 0. So we're going to do a sum one more time. And our sum, right, it's going to be 0 for both of these plus 1. We're going to push on 1 mod 2, which is 1. 1 divided by 2 is 0. And then we're going to be finished. So I think this should work. It says, are you in a type string or 0 is not assignable to parameter type string? Which makes sense. I think what I wanted is something like this. Because you cannot it's a strange output. Let's just print the stack to see what we have. So let's just see what's going on. We're iterating from the end, right, which equal to 1. I think this digits index thing is a little bit messy because what's actually happening is that if we get the last index of 1, it's going to be 0. So we do 0 and 0. And then we do digits index minus equal 1. But carry shouldn't even be 0. And I'm also length minus 1. We might have overcomplicated this just a little bit. So shortest is going to be B. Length of B is 1 minus 1 is 0. Digits index is equal to 0. So we're going to do parse int of A sub digits, digits index, which is 0. Oh, right. So we're actually going in the wrong order. It's actually an interesting problem. I think we could fix it if we just reverse the string. We have 1, 1, and 1. Problem is that the arrays start like this. So if we take the shortest, we end up saying, hey, let's go to 0. 0 is actually the first element in both of these. But even if we said take the length, the only way this works is if we reverse the strings already, and that'd be easier to see if our string was something like 1, 1, 0. If we pre-reversed it, then where they start would actually be the same spot. So if we had something like 0, 1, 1, we now have something like 1, 1, 0. Or if we give it an extra so maybe we could do something like this where we do reverse a string, we'll return a string. We're going to say let word equal this, and we'll just do let I equals s dot length minus 0. I is greater than or equal to 0. I minus minus, do word plus equal s sub I. Then you can just return word. Since they're reversed, they should now start at the same portion. And then we could just choose the shortest one still. If we're adding these two binary strings together, we'd have 0, 0, 1, 1, 1, 1, 0. Then if we reversed it, we'd have 1. Right, because we can't iterate from reverse because we don't really know where it starts, or we could buffer the front, but that's complicated. So we just reverse it. We could just do it in linear time. We just reverse the string. What you get is this. And you still get to add the string in the correct order and then stop at the shortest point. So I think this should fix it. We'll say arev equals first A, brev equals first B, and we'll replace A and B, arev and brev. So we'll just pretty much replace everywhere we had A and B with the reversed versions. And the other thing now being we were originally counting down, now we can just do digits index is less than shortest dot length. And then we'd actually add one because now we can just add them going forward. So if we were to do this now, we'd have A equals 1, 1, right? And B equals 1. They reverse exactly the same, but we can actually add them correctly now since we can now count up. Right, we'll do 1, right, digits index, which should start at 0. Right, A rev sub 0 and B rev sub 0 would be 1. 1 plus 1 plus 0 equals 2. We're going to do 2 mod 2, which is 0. So now we're going to push 0 onto the stack, right? And then go to the next value, right? Well, carry is going to be equal to 2 divided by 2. So carry is going to be equal to 1. They just have index plus equals 1. Then we're going to do 1, right, plus 1, which gives us 2. We're going to do sum mod 2. We're going to push 0 onto the stack. We're going to get another carry, right? And now digits of index is going to be equal to 2, which means this is not going to be why we're continuing. It's going to be because carry does not equal 0. These two should convert to 0, and we should have a carry stack push sum, which is 1 mod 2, which should be 1. Then we should still be able to reverse it. I think we should have to delete these 2 lines. I'm not understanding what's going on here. I'm still getting so I'm just going to print a rev, b rev, might be the shortest and longest thing. I think you actually can't compare 2 arrays in JavaScript like this. So I think that's where my problem is at. Shortest equal shortest dot length equals a dot length shortest dot length equals a dot length. So let's say a dot length is less than b dot length, right? Then a is the shortest, right? Otherwise b is the shortest, which means b is the shortest. Now does length of 1 equal a? If shortest equals a's length, then shortest would be b, otherwise it would be a. Now what if they're the same length? 2 is not less than 2, so we'll say this equals a. We'll say 2 equals 2, then this equals a is not less than b, so we actually get b rev, shortest dot length. The whole point of this whole thing at this portion is just to make sure that we only iterate on the shortest string. Now I think we could put a hack in. We'll just say, well, no, these are strings, not arrays. So we should be able to tell if shortest equals a rev, then longest should be b rev, otherwise it should be a rev. So we're going to print that to check. Shortest, longest. So shortest and longest does work fine. I'm actually not understanding then why could it be yeah, I'm not understanding. Let's try and print the sum. Let's check the sum and the carry after the first. So carry should be non-zero, but it's saying carry is 0 here. If our sum is 1, I guess that's our mistake. Our sum should not be 1. Yeah, this is, we're just getting caught in. Maybe we'll just pull this out and we'll just say brev. And then we can just say num1 plus num2 plus carry. And then we can just do num1, num2 and see what's going on. So yeah, I'm so confused as to why this is running forever. Digits of index equals 0. 0 is less than shortest dot length. Equals 1. 0 is less than 1. You're just getting a ton of nons. For our first one, we get 1, 1. Our sum is equal to 2. Right? And our carry is equal to 1. Then we have another line where our sum is equal to 1, which makes sense, but I'm guessing the 1 is not a number, but I don't understand why it's not a number. And I think I see why now. The way we used %, % only can take a string. So if the value doesn't exist, then it's undefined. So if it's undefined, we'll just give it the string version of 0. So let's try to use the example test cases. Oh, I always forget with these problems. At the end, you still have to and then in the end, we realize that what we really want is to go over longest length. You still want to copy the remaining numbers over into the number. So this is very slow. What if we remove all these console logs? It's a bit faster. I don't know if you can remove the reverse portion. I'm wondering if we could remove this part right here. We don't want to use don't want to use shift, because if we do shift, then depending on an arbitrarily large like stack or array, then it would actually be a bit of a problem. Because instead of, we'd remove this reversal part, but we would basically have, every time we unshift, we add an element to the front, we'd have to shift, we'd have to allocate a new array, I think. Or maybe it depends on implementation. If we were to shift, or we unshift, add the element to the front, that way we wouldn't have to reverse it. I think that would actually give us like n squared time. But I'll test it. I will test it here. We have return binary. Instead of doing push, just do unshift, and then we could just do stack. Or actually it's yeah, it's an array, so we can just do stack.join, I think. Yeah, it's about the same, I guess. So yeah, this problem is a mess. I think it's partially because when we do other problems like this, I always struggle to make sense of the addition. So we need to read an entire math book, because this was bad. But the problem is solved, and that maybe there's some value to these easies. Let's check the solution. I forgot to say the time complexity. Given any string, right, we have to do A plus B operations to reverse it. Then we do, I guess we do the max of, you could optimize this A reverse and B reverse to do both of them at the same time to save time. So we'll just say that we'll actually end up doing the max of A or B. Then we do the max of A or B here. And then we do the max of A down here to reverse it or not, right, depending on how you do it. That's basically 3A. So I would say this maybe is linear time. And our output string, at worst case, our output string could be one element longer after it. Actually, no, it could be much larger. But I think it can only be, actually no, yeah, it could go pretty large. Space, I would say this algorithm would be O of, for time complexity, the max length of A or B, and then space, I want to say it's A, or the max of A or B, but that doesn't make sense because two numbers added up could be much larger than that. But maybe at worst it would be around max of A. Oh, so we did get it right. It'd be max of n or m. So that's what we, this is basically what we did. So that's pretty cool. Yeah, this is probably the fastest answer. We'll say at least we got as good as we could get on the first try, but it took an hour, so definitely things to learn here, but I'd say that is a wrap.